Hey, good morning, good afternoon to everyone. Welcome to our today's Six Sigma sessions. There will be a few sessions going on for this year and future next years. Okay, so my name is Pin. I'm the JMP SE. So let's see what we'll cover for today's topic. So all those will be the contents I'm going to cover in today's session. First, let's revisit Six Sigma. In last year, we talked about Six Sigma and the DMAIC DMAT. We also mapped the DMAIC DMAT statistical analytics to our JOM analytic workflow. And we have 3 sessions, which is Amanda already put into a website, which is called Six Sigma Cheat Code e-guide. Feel free to get your free e-guides sessions. Okay, let's move on for today's topic. Today, we are talking about 2 major parts. One is a problem definition. The second part is a process improvement. Okay, so for any of the Six Sigma DMAIC project, DMAIC, define and measure are very important, right? Albert Einstein once remarked, if I have an hour, I will spend 55 minutes thinking about the problem, another 5 minutes to think about the solution. Okay, this maybe sounds a little bit extreme for me as an ordinary people, but what he wants to emphasize is the importance of the define phase, which is in problem solving before we really rush into, the solutions. Okay. So what is the ultimate defined outcome? Can I ask a question to those attendees? Let's say you join today's sessions, you may a DMAT trainers, Six Sigma trainer or practitioner, at least that you heard something. So what do you think is the ultimate defined phase, the outcome? You can type in your answer in our chat window. Let us know, okay? This is the first one to exercise our, what will be the ultimate defined phase, the outcome? Is anyone know? Please feel free to type in your answers in the chat window. Get clear, objective and sponsorship. Yes. Define the problem. Yes. Agreement and common understanding. Yes. Many of the answers coming. Know exactly what we want to do. Yes, exactly. Agreement and common understanding. Yes, you get it right. The ultimate defined phase outcome is our project charter. Right. Project charter to clarify the focus, scope, direction, timeline, motivation for the improvement for the team. And another very important thing is essential to secure our stakeholders to approval so that we can get the resource allocation and budgeting so that we can carry on our Six Sigma project, right? Not only for Six Sigma project, for any type of project, it is very important for the project charter. That's why we must strive to understand the problem before we go for the project charter. We need to assess the process performance to quantify the ability of the current process instead to meet our spec requirement to understanding our customer, either they are internal or external, to setting a very clear project goal. How much we can go in what time zone, so on and so forth. If you look at all those stuff are something that is defined in the measure phase, right? That's why I say measure is a very crucial for us to define the project charter. So together, define and measure phase are fundamental for us to set our smart or smarter goal for any of the project, especially for our Six Sigma project. Define and measure, they are not to be done separately. They are doing together, right? So for today, let's talk about the problem definition and process improvement. So for today's session, I am only focused one customizable jump add-in, which is we call it more than Six Sigma jump add-in. If you do not have at this moment, don't worry, we will share this add-in to everyone free of charge, right? So for this more than Six Sigma add-in, I already installed in my jump so that it will appear as one of the selection menus. From there, you can see I have a define, measure, analyze, improve, and control, so on and so forth. DMAIC, follow the step. We also provide some of the samples, which is help you to practice some of the platforms and also the reference. In the sessions at December, Kinghui will run through how to install the Modern Six Sigma add-in and how to use it in a high level. But today for my session, I will go to a deep dive about measure. So particularly there are four platforms that we are going to use. First one is Pareto and the EDA Graph Builder. Okay, then the second demo, which will be talk about the capability analysis and the explorer. That's why from problem definition to the process improvement. So far, are we all clear? Let me know before I move on. If it is very clear, give me a thumbs up or any of the yes. Thank you very much. I know you guys are listening. Cool. Let's move on to our first topic, which is talk about the problem definition. This is the first thing we need to do for any of the projects, right? So we use a Pareto chart, we use 80-20 rules or principle. Then Pareto chart is one of our traditional 7 or 8 basic tool of the quality. If you attend some of the, let's say, Six Sigma or quality related training, you may happen to know all those one. Why I say it is a traditional? Because some of this is a little bit outdated, especially in high-tech company. Let's say ChatSheet. We are no longer using the handwriting to key in this, but still valid in some of the company, which is not that high tech, right? That's why I say it's traditional 7 or 8 tools, basic tool of quality. But the concept is still valid. The concept still valid. The way how we make use of the Pareto is still valid, but how we do the Pareto maybe is changing. So Pareto chart can be done easily anywhere. You can use any of the software, easily come to the Pareto chart. And you can even using the Excel to do so. Let me show you one example, which is I am using the Excel file to do the Pareto chart. So I want to show you using Excel file, what will be the headache things we are going to, encounter. Okay, so if you see my Excel file, this is the type of semiconductor defect. We summarize all type of defects, the total count, and also the defect image data in a nice Excel table that is I put here. Don't worry if you are not coming from semicon, you can be think about any type of a defect that you are dealing with or any type of a hazard. Let's say from ESH point of view, can be any of the things, okay? Don't worry. So let's see this type of defect. I want to do a simple bar chart, which is a type of Pareto chart, but for this case, in not sorting in the sequence from the highest to the lowest. So what I did is I am going to sorting the data table over here, sort the table so that it will follow the Pareto rules from the highest to the lowest. So from here, I just sort my data based on the value of the total count. You can sort by lower or higher, largest to the smallest. Okay, I sort my data, I get a nice kind of a Pareto chart. Of course, the accumulate line, I didn't edit. Okay, this is only for illustration purpose. I manually sorted my data. Oh gosh, do you notice, some of you, do you notice my metal scratch? Where is my picture for the metal scratch? Oh, is this one? Yes, is this one. See, I did something for my chart, but the picture, this is the thing for the picture. Picture itself, they are not insert the individual cell. So that, let's see, once you do something to your Excel table, those will change. Another thing is, let's say after the DMAT project, our team able to solve the metal bridging, which is seems the top one. Let's say you lost contributor. Now I do my second Six Sigma project. I will delete this defect because I already fixed it. No more metal bridging. So I will trying to delete. Oh my goodness, this metal bridging, how come is still here? The picture is still there. I see the headaches since because the nature of the picture is not insert into the individual cell. Okay, anyway, forget about the picture since now I get my Pareto is done. So what I'm doing is I am going to put into a PowerPoint. I copy my Excel into my PowerPoint. I start new PowerPoint over here and paste over there. Let's assuming I am a newly joined engineer or scientist. I'm not familiar with all type of defects, especially with their image data. I don't know which one is which one. That's why I copy carefully one by one to match their Pareto, the names. I trying my best to copy one by one. Right? So in the end, I will get a chart, something like this, right? Some of you may already know, okay, metal scratch, actually, this is not the metal scratch picture. Well, I exchange with this metal bridging picture because I am a new engineer. What's going to happen for me? I make a big mistake in front of the manager, in front of my seniors. Who can guarantee you cannot make a mistake during so many copy and paste, during the difficult of we using the Excel? So I need sorting my data. I need rearrange the picture manually. I need copy and the picture so that to make my Pareto chart looks like much more informative. But what about the accuracy, efficiency, effectiveness? None of them. That's why we encourage you to use the JMP to do the Pareto chart. Do not use Excel, even though it can do, but don't use it. So in JMP, you got two options. One is the traditional. You can use quality and process under analyze the quality and process Pareto chart. You can use this one, or another is a modern Six Sigma, which is the add-in, the single add-in I am going to use for today's session. That is the Pareto chart. Okay, this is the platform I'm using today. So we also have the sample data that is ready for you integrate into this add-in. Is over here, defect Pareto. You can just open this one and give it a practice later on after this session. Once you open this JMP table, you will see the defect and total count. And for your easy convenience to practice, I already embedded the script for you. Just click the run, you get two charts. The second chart is the graph builder to showing you the defect Pareto, kind of similar defect Pareto, while the first one is the traditional defect Pareto. If you want to do the start from the scratch from here, more than Six Sigma add-in, under measure Pareto, you can just put the total count over here, type of defect into here. Here you go. You will get the same Pareto, but of course, the appearance wise, you need fine tune a little bit. Let's say I also have each of the indicator, each of the point to tells me the accumulate what is the percentage of the few type of defects. Okay, so this is the first thing. Once you use the software, you no need to do the sorting for the data, so on and so forth. The software will handle everything for us. Okay, so for some of us, we already noticed there is a hidden column in the file that I hide from you. So right now I can unhide. Oh, you will see this is the image picture I using just now in the Excel. But in here, the image information, unlike what we see in the Excel, it is one of the cell content. It's also same as other cells, right? So how do we use the image? Okay, just the right click the image, we can use it for marker. Okay, we can use it for marker. What's going to happen? Remember this Pareto chart? Okay, just now all the markers now will be replaced by the picture. So you will be very clearly to present this to your manager, to your stakeholder. They will see the first defect is this, how much does it contribute? The second one is this, how much does it to contribute, so on and so forth. Just now the data point right now will be use a picture to replace the data point. This is for Pareto chart. Well, when we look at the graph builder, graph builder is stands for us to do the exploratory data analysis. Remember just now the single data point will be replaced by the picture. So once you copy this picture, let's see, you can copy this picture into a PowerPoint. Here, I can copy and paste as a picture. So you will get your Pareto done without so many of the manual sessions. You can also paste with enhanced meta file. The enhanced meta file, what's the beauty for this one is once you increase the PowerPoint, let's see, you see the data itself is still in high resolution. That's very good when you submit any of the symposium, when you go to any of the poster, they are require high resolution picture and wording. So while if you are just the paste as a picture, not so clear, not so clear. So just a paste as a picture, it will be much clearer. So you see, make use of the picture, make your life so easy, right? If you go back to here, so another thing is come to here, graph builder. We know graph builder is much easier for us to visually display the data. You can change the order, either descending or ascending, or either no order, just up to you. For example, just now we say after the Six Sigma project, the metal bridging is no longer an issue. Then let's say I am going to delete this metal bridging, delete this row. You see the metal bridging, the whole row is gone. The picture is gone. Everything is gone. If you come back to here, the picture is no longer showing you the metal bridging, right? So anytime, let's say after your project, you finish one, you settle one defect. For example, AA bridging, I done, I finish, I kill this defect, no longer have AA bridging. I delete this one. So in the chart, AA bridging also is gone. This is a linkage between any of the cell data table and also the jump pictures. So anytime you say, oh no, this AA bridging come back again, you can undo, or your metal bridging, AA bridging will come back again. Okay, so let's trying to summarize this one. So for the Pareto, no matter you use the standard way or you use a more than 6 sigma this measurement Pareto, the same launch interface and the same Pareto result, you get a standard Pareto result easily. Not only this, because we are doing more than 6 sigma, use the picture as a marker will make your Pareto much more professional, modern, right? That is why we call it modern Pareto, unlike the standard Pareto. Add on a little bit pictures, right? Similarly, you can use our EDA, exploratory data analysis platform, which is the graph builder, to do a modern Pareto. So you can easily sorting the sequence. Once you kill any of the defect, the picture will refresh. Because why I keep emphasize this one, because we know one picture is better than 1,000 words. Trying to use a picture, put some of the picture into your Pareto, into your data visualization, so that once you go for presenting, so the information much more clear, much more visual, no need additional language explanation. The people, when they see that, they will know it easily. So all the problem just now we are demo with you with the Excel, no longer a problem. Now it's easy peasy, right? But of course, I'm demoing it very fast. If you have any question regarding this session or you want to schedule a further in-depth, let's see, kind of a demo, let us know. So I hope so far is so good. Let's move on to the second topic, which is process improvement. Talk about the process improvement. Stable and capable process is always our goal. We want our process to be stable and also capable. In order to achieve that, we need to carry on a lot of process improvement activities, right? The first question for process improvement question, we want to ask ourselves, where are we? We need to know, understand our process status quo, the current process performance. We need to carry on CPCPK analysis, so on and so forth, right? So the second question is very crucial. Once we understand where are we know what we want to achieve. The second question is coming in is how, right? You only know how, then you will be easy to progress effectively. If you don't know the direction to achieve your goal, whatever your effort will be wasted. So understand how should you do is crucial in order for you to achieve your goal. As we know, the CPK is the function of the mean and the standard deviation. So is the mean away from the target or the standard deviation too big? So what is the direction? How should you do? Once you clear this one, you will achieve your goal through this 6 Sigma project, right? So you may carry on to do the continuous improvement process to achieve one goal, another goal, another goal. This is a continuous process improvement, CIP. So today, for today's session, we only focus the second one, which is how, because this is more important, right? So let me come back to jump. Let me close all others. Okay, so that is the how part is what we are going to cover for today's session. Okay. For this one, we are going to use a sample data called semiconductor capability. You can find it under Modern Six Sigma sample data, semiconductor capability, or you can find it under the help menu, which is the sample data index. You can just search semiconductor index. here you go. You will get the same sample data. Okay, so let's just using under the add-in sample data semiconductor capability. So similarly as the early one, you just need to run the green button to run the embedded script, you will get it. If you want to do it from the scratch, you can go to Modern Six Sigma measure capability analysis, put the process over here. Here you go. You will get exactly the same capability analysis result. Okay. So of course, under this capability analysis result, there are many other information provided. There are many others. For example, the detailed summary report, including the CP/CPK, which is to tell you where is our current status quo. And we also have a lot, not only CP/CPK, but also PP/PPK. But what's the difference? When to use which one is better, CPM, CPK, CPR, what's the difference? All those one we are not to cover here. But if you schedule in-depth, let's say 1 hour and a half or 2 hour sessions with us, our SE will explain everything in very detail. But today for our sessions, I will use the CP/CPK or PP/PPK interchangeably, okay? So you also have a process performance graph. We also have some others, but we will not cover that part. Let's just focus the goal plot. Goal plot. The goal plot, we understand just now the CPK. For those, if you don't know CPK, the formula calculation, you can Google search. CPK, the calculation is a formula of the standard of the mean, sample mean, and also the standard deviation. That's why only these two indicators, one is a mean, another is a standard deviation. That's why I come back to this goal plot. It is a two-dimension graph, present the performance of the process in two dimensions. On the X is process speed limit versus the standardized mean, which is to say, if my process is right here in 0, along this 0 line, that means my process is quite right on target. If they are onto the right side, that means my process, the calculate mean actually is higher than my speed limit target. Okay, target. Same, of course, same calculation for the lower part. So this is for the X dimension. Same for the Y dimension. We have the spec versus the standardized standard deviation. So the ideal case is I do not have any of the process variation. This is the ideal case, but of course, no. The higher it goes, that means my process range is very wide. My process sigma is too big. Of course, you can change over here to adjust the display, a zoom. But let me showing you how to use this goal plot. So for any of the process, you see there is a data point over here. You can see from the chart here, this data point actually is on the X dimension quite aligned in 0, but slightly a little bit towards the lower side. I can conclude from this chart, let's say this process actually is quite on target, slightly lower, but quite on target. While for the standard deviation, is a range so big. Let's take a look whether it's true or not. You can just mouse over. Mouse over, jump will bring you the next level deep dive individual trend chart, which is the control chart builder. We are going to use it in the Modern Sigma control phase. We are going to use a lot control chart. But here, of course, in the measure phase, we also need to use the control chart. So the control chart, it will give us individual chart and also moving range. So from the chart, you can see my upper and lower spread limit actually is very narrow, while my process is a range along my spread limit, up and down, right? It's a very big variation. And from the capability analysis histogram summary table, I also can see summary chart. The range is really, really big according to my upper and lower spec requirement. And from the data point of view, this is a graph point of view. Well, by looking at the data itself, the target is 64.49. My sample mean is 64.40. Quite well on target, slightly to the left side. While the sigma is about 2.5. It's very big. From here, you already can see, but this is just from the data perspective, okay? Qualitative and quantitative, both way. JMP will present you in both way. So with this one, you can easily to identify, oh, where is the direction should I go? So I ask you a question. If you are the owner for such a process, so obviously the sigma is very poor for this process. How are you going to do? You can type in your answer in the chat box. Let me know, and also test a little bit your understanding. So in order to achieve my CPK requirement as higher as possible. Right now is too low. So as a process owner, how should I do? Type your answer in the chat window. Need improvement, too many out of spec. Yes, you're right. Reduce sigma. Yes, tighten standard deviation. Exactly. Thank you very much. Thank you very much. You get it. With this goal plot, it will already identify the direction you want to do, right? And further enhance with some of the process capability analysis in detail. You are more confirmed, oh, which is the direction I want to go. Tighten your sigma. Of course, there are many different ways to tighten your sigma. Either you dedicate some of the material or some other things, you can do it, right? Or you can change your equipment, so on and so forth. So this is the direction we should understand. Very important is the direction. So the next question is come. For any of the Six Sigma, we need to set a target to achieve. So you see, I want to reduce my standard deviation. So how much do you need to reduce? How to answer the second question is we can use a tool under this triangle, which you call interactive capability plot. Okay, so by looking at this plot, this is still a distribution chart. You can see in center, this is our spec limit, right? This is our spec limit. So our current performance is too wide. So let's see, here is my new process. This is the original process. Let's see, you want to reduce your range or the sigma. So how about right now it's 2.5. If I am ambitious enough, how about I say I reduce half to maybe 1.2. You can put 1.2 as your project goal. So what's going to happen? My CPK, of course, will improve. Is it good enough? Not really. Far away from, let's say, 1.33 or 1.67. At least you get some idea. Otherwise, without this one to visualize, wow, you see, I reduce 50% of the standard deviation, a big achievement. Actually, the big achievement to the CPK, not really. Maybe you need further reduce, let's say, very aggressive 0.2. Yeah, it's quite high. One is already one. It's quite high. Can your process do so? I am not sure. But at least with the interactive capability plot, it will visualize when our project goal, let's say I achieve this Six Sigma reduce from 2.5 to 0.2. I achieve this goal. Of course, this will be your CPCPK result by then, right? But if some of you use this one, if some of you may have another idea, what is the quick win to achieve our higher CPK for this case? What is a very quick win for this case to achieve a high CPK process? A quick win. Anyone knows? Yes. Adjust the upper and lower spread limit. Widen the spread limit. Yes, exactly. Because our CPK is a formula of spread limit that is given by customer or you promise to your customer. Another is the mean and sigma for your own process. Mean and sigma is something that you can control. For this case, maybe your process if actually is stable but not capable. So you may propose to your customer, say, hey, can we loosen or widen the upper and lower spread limit? If they agree, you do nothing to your process while you still achieve your goal. So, but with the capability plot, you can visualize, you can answer the question, what if? So today we introduce the first one, using the goal plot to identify what's wrong with your incapable process. I know it is incapable, but what's wrong? It either is the process mean or the standard deviation. Another thing is could be the spread limit, which is I not put here. So the second one is using the capability plot to simulate what will be for your process improvement activity. Because in the end, you still need to quantify your Six Sigma project, right? You want to know, oh, if I doing all those activity I achieve, then what will be the result? So what will be the tangible result, right? So yeah. So I give you a little bit bonus, which is called Capability Explorer, or some of you may heard about six-pack report. Actually, this is already ready to use a JMP in our community. But for our modern Six Sigma, we repackage it into the measurement into a capability explorer. Okay, so how to use this capability explorer? You just put any of your process in variable. Here you go. Then why it called six pack? My understanding is they just very simple, give you six pictures. The first one is the individual chart. The second one is a moving range chart, histogram, and the QQ plot, and the box plot, and also observations for the last 25. In JMP, this Explorer, you can be freely to change your observations. You want to see the last how many, just feel free to change. But I will say, yeah, if you like to use this way, feel free to do so. Otherwise, I will say our JMP, this one got everything that you need in one page. In one page, you can do all the things like what I say. And using the drill down, you can get it. So this is just a little bit bonus talk about six-pack report. Okay, let's recap for this session. So knowing how should we do is very important for process improvement activity. Then once you know how should we do, just do it, right? Just do it. So the final recap for our today's session. Today we using the Six Sigma Jump add-in, which is consists of a DMAIC, 5 different stages. That is all the stages, the software, the platform that we are going to use, right? But for today's session, we only focus about the measure, talk about Pareto and EDA to do the problem definition, to visualize our problem. And second part, we talk about the capability analysis, how to identify the direction, how to quantify it. So in the next month's sessions, I will talk about measurement variation, talk about type 1, type 2, MSA analysis. Okay, that's the upcoming session. With this, I will end my today's presentation. I will